That's unfortunate. So we guessed that last spot of 9.4. And then we know we need 4 positives, so we're going to grab our calculator to see if we can get the rest of them. So we're going to type in our function. Three plus 2 cosine quantity x minus 5. And then in the next spot, you're going to plug in y equals 2. And then I want you to scooch this all the way back and press enter. And what that'll do is it'll just give us a nice thick line across for us to easily see the intersections. Okay, if you have a newer model of the calculator, it's in different colors and nobody worries about it. But this one, mine's in black and white. Not so great because we have to do what? First of all, it looks like this problem's in radians and I'm in degrees. So I might want to change that. And then what's the other thing that might be causing a problem?
I have to ask you.
Okay, so this is obviously more than 4 intersections, right? We only need 4 of them, so we have a little too much. So let's go ahead and change our window. X minimum 0. Do we want our X minimum to be 0?
Oh, well, we want it to be less than 0. We want to see what's like beside that.
Okay, so let's go -1. Whoa, that's -22. No. Okay, X maximum. Do we want our X maximum to be 54?
No.
Probably not, because we're here at 11.4 and we have possibly 3 intersections. We only want how many? 4. So what do you think? Okay, Mila, go. Go ahead and set it up for her, please. So what do you guys?
Go like 15 to see the next drop.
Yeah, we'll do. 15 is a great call. 1 to 15 by 5s. Probably not. It's not looking good. Very little. Okay, maybe I'll go by 2s. And then y minimum. What is our y minimum?
1, not 2. No, yeah, 1.
So the lowest it goes is 1. So maybe I want 0 or maybe -1 just so I can see the axis. Personally, I like seeing the x and y axis. It's helpful for me, but you don't have to. Y maximum 14. Do we need to go all the way to 14? No. What do we need to go to?
6.
Yeah. And I can go by 1s from -1 to 6, right? Okay. So now we'll sketch it and see how many intersections we get. We have 4. Exactly. It looks like we have 4. And so we're good. So here is, what do we go by, 2s? 2, 4, 5. So here's our top where we started right here. See that? Because we scaled it by 2s. So this is 2, 4, 5. There's our top, which means it went back. And it went back and actually grabbed 2 more by going backwards. So we don't even need this one that is forward. Okay, so now we're going to go ahead and grab all the intersections. We want the first 4 positives. So the first positive one looks like it happens right there. That is the first positive one. Do you guys know how to find that spot?
Intersection.
Yes, press second and trace. Number 5 is intersect. First curve, is this what we have in Y1? Does that function look right? Yes, press enter. Says second curve, question mark. Is that what we have in Y2? Yep, press enter. Next it says take a guess, meaning I just need to know which one you want because there's lots of intersections. So let's start with the first one. So move your turtle all the way back, your little turtle, all the way back to the very first intersection. So I want like that one right there. And you just have to be close to it, somewhere next to it. Okay? And then you press enter. And it says that first intersection is at 0.81. So y sub 1 is 0.81. We need to find the first 4. So you guys need to quickly find the other 3 by doing the exact same thing for the other 3. Did. Camila, X2, your second one?
I got 2.91.
2.91?
Mm-hmm.
What'd you get, Jordan?
I got 2.905.
Okay. X3, Jordan, what'd you get for X3?
7.094.
Mm-hmm. And Camila, the fourth one, the last one?
9.18.
8?
Mm-hmm. 8, yeah.
Perfect. So these are the first 4 intersections. You would write them as a solution after you got them out of your calculator as a final answer in order from least to greatest. Like that. And this is where the part we did yesterday comes in. Solve example 2 by hand. We call that algebraically. So the calculator did all the work for us and got these answers. We need to be able to solve them algebraically and do this by hand. So here's what we have. Y equals 3 plus 2, cosine quantity x minus 5, and y equals 2. Our job is to get all these answers that the calculator got, but by hand, okay? So basically we're doing the same thing the calculator did. We're solving for the intersection. So what would the first thing you would do if you had these 2 equations?
Can you set them like equal to each other? Because they both equal y.
Hi, Nick.
Thanks, babe.
Hi, I'm glad you're back.
Hey, man.
What do you do?
I'm chilling.
All right, Nick, you want to help us out?
With what? Oh, that?
How to solve that system of equations? First step, first idea. What would you do?
Can you set them equal to each other?
Where's my light bulb?
I don't have a light bulb.
That's the light bulb moment. All right. I can set them equal to each other. So what is... I shouldn't eat those anymore. What is y equal to?
2.
2. Yay. Okay, next step. What would we do now? Solve it. Okay, what am I solving for?
0, Jordan. Yeah, make it equal to 0.
Not this time.
We're recording.
Oh, you're recording how long it's going to take?
No, we're just recording.
Oh.
For anybody that's not here.
Well, they
So you're on there. You're on there, Nick. You're on the recording.
sit.
All right. So what's our first step? You're right. We're solving for x, which means we want to get x all by itself.
So subtracting.
Uh-huh. Okay. Now what?
Now, divide by 2.
Mm-hmm. Cool. Okay. This goes away, right? Okay. Now what?
Oh, now, hold on, wait.
Well, think about it. Hold on. Think about it. Think about it. What do we want to get rid of?
Cosine
Cosine. How do we get rid of cosine?
divided
By cosine. Oh.
by cosine inverse.
Take the cosine inverse of both sides. We undo cosine by doing the cosine or taking the cosine inverse, right?
Add 5.
Ooh. Normally, this was an honors pre-calculus, right? If this wasn't a calculus thing, we could just add 5 to both sides and call it a day. However, we said at the very beginning, we want all possible answers, not just the one the calculator gives you. So, stop sign. It's a pretty bad stop sign. Come on, draw your stop sign. Stop. All right, so there's our stop sign. It is Watsonville High. All right. It's a G. All right. And tag it. Tag your stop sign. All right, so really important. Cosine inverse. If I want all possible answers, I stop here before I add the 5 and I use arc cosine for all possible answers. Because if I plug this in my calculator, it only give me 1. And what was the goal of the problem? To find the first 4 positives. I can't get 4 positive answers out of one thing, right, from the calculator. So, Camila, now you can grab your notes. What's the formula for arc cosine?
It is.
I'm going to do this. Stop sign moment. Continue over here.
Oh, we are on radians, so it's plus minus.
Good. Uh-huh.
Cosine inverse x plus 2 pi n.
Mm-hmm. And x is the value we're using, so we're using quantity of negative 1/2, and then plus 2 pi n. And now this is the formula for arc cosine, so now we can set it equal to x plus 5, and whoa, thinking ahead. I hate when my brain does that. X minus 5. And now, Jordan, we can do the last step. Add 5. Huh? Okay. So we end up with 5 plus or minus cosine inverse negative 1/2 plus 2 pi n equals x. And this is where you guys can finish it off. How many cases do we have?
4. No.
Well, we want 4 answers, but look at your equation. How many cases are there going to be? 2, because there's a plus or minus sign. Remember we did this? We said there's 2 cases, the positive case and the negative case.